This paper is entitled "A Method for Investigating Links Between Discrete Data Features in Knowledge Bases in the Form of Predicate Equations." The following problems should be solved here. A method for investigating links between discrete object features is to be presented. A classification task in the form of predicate equations should be formulated mathematically. And other points listed here. We have analyzed the current research in the field of logic classification. There are many different approaches, but many of them use Boolean equations, Boolean algebra, as a tool. Here is an example of representing knowledge in the form of predicate equations. These equations generalize in some way Boolean algebra and gives us more flexibility in solving problems. Here are possible tasks for solving such equations. This is a system of equations for classification purposes. In this case, the system can be rewritten in the form of a single equation. Classification problem, in the sense of logic classification, can be represented as follows. When we have some a priori dependence between objects and their features, and then we formalize this problem in the following way. So the problem is reduced to the solution of a functional equation. This is a general case. Now let us switch to a particular problem that we consider here when we want to investigate links between so-called non-salient variables. We should delete these variables with the help of logic quantifiers. These are some important properties of existential quantifier that allows us to delete these variables without any increase in the size of the original formula or a system of equations. This is a way of a recursive construction of a special class of predicates from which we can easily extract necessary dependencies. The same problem can be defined for universal quantification. It is represented here. These are some important properties of the universal quantifier that allow us to do the same thing, to simplify the formula with the help of the universal quantifier. We can construct a class of predicates from which we can delete non-salient variables with the help of universal quantifier. We have considered a real-world medical example for heart diseases. We can see on this slide some aggregated features that characterize health groups. With the help of these health groups, doctors can classify patients regarding their risk group. Our task was to find some dependencies between these features in this case, excluding some features that are not of interest to us at the moment. So, as you can see, we obtained a simpler formula. And again, we can delete variables from it further if we wish. In this paper, finite predicate equations of different types have been considered. The description of classification problems based on predicate equations have been presented. The problem of object classification on the basis of features taken on discrete values has been described mathematically as a solution of predicate equations. A broad class of predicates from which it is possible to delete extra variables and focus on links between salient variables has been described. A method for deleting non-salient variables by the application of the existential quantifier has been suggested and demonstrated on a real-world medical example. Although some variables in the medical example can take on values unknown, we deal with the closed world as unknown. Some features take on values unknown, means just an element from the domain for the variable. All the domains are strictly defined and cannot be completed with any other elements. The main advantage of this method, based on a specific structure of predicate systems, it lies in the fact that after deleting non-salient variables, the original system is simplified, which is due to special properties of quantifiers. Salient variables are not necessarily fixed forever. It is up to researcher to decide what logic connections are important at the moment. Thank you for your consideration.